Hey, Brian, you're muted.
Got the mute button this time. Good evening, everyone, and welcome to Mount Washington Observatory's Science in the Mountains with program support from MathWorks. My name is Brian Fitzgerald, and I'm the Director of Science and Education here at Mount Washington Observatory. And joining us this evening to discuss winter weather in a warming world is Dr. Elizabeth Burakowski, who's a research assistant professor at the University of New Hampshire in Durham. Thanks so much for joining us for tonight's program. For those of you who aren't already familiar, the Mount Washington Observatory is a nonprofit, member-supported organization whose mission is to advance the understanding of the forces that create Earth's weather and climate. And the way we accomplish that is through operating our Summit Weather Station with around-the-clock weather observation and forecasting, by conducting research and product testing, and by developing and offering innovative educational programs. So if you have some questions for tonight's speaker and are joining us via Zoom, please use the Q&A button. You can find that at the bottom of your toolbar in the middle of your video screen. We are definitely able to collect questions throughout the entire program. So as they come up, please put them in there and we'll have time for a live Q&A session. So be sure you get your questions in. If you're joining us on live stream on Facebook, welcome and thanks so much for being with us. We won't be able to respond to your questions during this program. However, our Summit staff will try and respond as quickly as possible following the program. If you'd like to connect through Zoom for our next program, please register using the program links on mountwashington.org/SITM. Alrighty, so right before we kick off the program here, let's get things going with a poll for everyone. So just a couple questions or a few questions here to kick things off. So if you're on Zoom, feel free to participate. We'll give you just about a minute or two here to answer some questions. We're curious, for starters, where you're joining us from. Perhaps somewhere in New England, perhaps outside New England, maybe outside the country. Welcome. Curious, are you a member of Mount Washington Observatory? Don't forget, we are a nonprofit, membership being an important part of what keeps us going year in, year out. We have a few options, yes, no, and no, but after this great program, I'll become one. So no pressure, Liz. All of our support is on you tonight. And lastly, Liz is curious because this will definitely influence a little bit of who Liz is talking to this evening. How would you categorize yourself as a winter recreationalist? A skier, rider, glider, slider, other, none of the above? Feel free to select one of those options right there. And I'll just wait for a few more folks to put in some of their selections and we'll show some results here. Alrighty, let's end it. 3, 2, 1. And let's share some results. All right, New Hampshire is the big winner this evening. 35% of you, about 60 folks so far, joining from New Hampshire. Not so far behind Massachusetts, and then folks from outside New England as well, and even 4 people from outside the country. Welcome. Glad to have you with us. Pretty good breakdown in terms of membership versus not, though. I'm very excited and thankful for those 15 individuals who said they are going to be so excited after this program, they'll become members. So thank you in advance. And then lastly, it looks like, well, we broke down between skiers taking up 29% of our audience here and other, whatever that might mean to you and how you enjoy winter recreationally, takes the cake at 32%. So let's stop it right there. And without further ado, I would love to hand things over to Dr. Elizabeth Burakowski. Liz, thanks so much for joining this evening. I'm guessing you can hear me okay.
I sure can. Thanks for having me. I'm so excited to be here.
Excellent. We're happy to have you too. Why don't you take it away?
All righty. Let me set up my PowerPoint here. Okay, let's start. All right. Well, thank you everyone for taking time on your Tuesday evening to spend some time with us and learn a little bit about the research we've been doing at the University of New Hampshire and beyond, and to study winter warming. You might have noticed today it was quite warm. I went out in a tank top and shorts today for a run because it was about 74 degrees here in Durham, quite a bit above average. So to get started, I do like to always start at the very beginning. This is my twin sister and myself. We were actually in Wisconsin at the time, and shortly after this photo was taken, we did move to New Hampshire. You can tell which one is me because I got the gigantic dimples. Twin sister does not have dimples, but here she is in pink and I am here in the blue. And when we moved to New Hampshire, of course, one of the first things my parents did was go to the local ski swap, and they bought us some cheap pair of atomics that were used, and we went skiing at Suicide Six. Now, Suicide Six is the longest running lift serve mountain in the United States. So it has a very special place in ski history in the US. The original J bar right down here was installed around the mid 1930s, and it's still running today. Or the last time I went to Suicide Six, it was not for skiing, it was actually for the start of the Covered Bridges Half Marathon. So what's really nice is to see how these resorts have been adapting to a change in climate by using many more of their facilities for other activities that might be outside the ski season. My next stop on my ski tour was McIntyre. Beautiful McIntyre is in Manchester, New Hampshire, our Queen City. So this is the largest city in New Hampshire, and it is a very small mountain, but very dear to my heart because it was my first ski club. This was in elementary school. I think tickets were probably about $15 at the time. I think they're a little bit more, but not too much more now. And my twin sister used to work here, not work here. She worked for the city of Manchester for a time in the 2000s. I believe it was, I can't remember the exact years. And when she was working there, she kind of had the inside scoop because she was the Leslie Knope of Manchester, New Hampshire, which essentially meant that she was working in Parks and Rec. And at the time, it really wasn't a moneymaker for the city. It's since changed hands and is under new management, and they believe they're still doing better. And they're still recruiting a number of people into the sport through ski club activities and after school skiing. Next stop and last stop is Pat's Peak. This is when I made the switch. I know there were only 2 riders in the group, snowboarders out there. I am joining you in that crew. I switched from skiing to riding at Pat's Peak, and I have very fond memories of riding here. At the time, they didn't have a terrain park. This is actually a New England map that didn't have, ski map that didn't have the terrain park in it. Instead, we would build jumps, and usually ski patrol would tear them down at the time. So this was in the 90s or so. Now, all of those resorts that are in my ski history, I'd like you to take a moment and think about the resorts, maybe if you were a skier, that are in your ski history. All of the ones that I went to and grew up with are still in operation. However, 600 plus resorts across the United States have closed since about the 1950s or so. And this is for various reasons. Some of them were very small. They had a boom bust cycle of many very small hills that only had a rope tow and simply just didn't keep going with the business once the bigger mountains started opening up and adapting snowmaking. Other ones were slightly larger mountains. This one here is Maple Valley, which only recently was sold after being closed for over a decade, almost 2 decades, and is reopening and reinventing itself as a brewery. This is in southern Vermont. It's a very low elevation mountain, and it would require quite a bit of investment in order to become what it once was as a ski resort. Now, there's various reasons for them. One of them is that we do see some warming trends. So I'm going to show you a map here. It's a movie map, and what it's going to show you is areas of blue are going to be cooler than average. So you can see a little temperature bar up here, and areas that are in red and orange are warmer than average. The blobs are going to move around. We're starting in 1880 to 1884, so it's about a 5-year average, and we're going to move forward to present day as the movie plays. So you'll note at the beginning of the movie, everything's pretty much blue. These things were cooler than average in the 1800s and into the early 1900s. As we move into the 1930s, you see the US light up in red. That's the Dust Bowl, very dry and hot period. In the 1960s, you're going to see the eastern US light up in blue. This is leading up to the Clean Air Act that removed harmful pollutants that were blocking the sun through aerosols from coal burning. Now we have cleaner burning coal, not perfect, but we also see another pattern emerge. And this is extensive warming, especially at the latitudes that are much higher up near the Arctic. Note that we also have this big red blob off the Gulf of Maine. The Gulf of Maine is one of the fastest warming bodies of water in the entire world right now, with consequences to marine life. But the focus of this one talk is much more on snow. One thing that scientists have understood for a number of years is that it is extremely likely that the warming you saw on that previous map is especially due to emissions of greenhouse gases, which are the dominant cause of warming since about the mid 20th century. So think around the 1950s, 60s, 70s, that's when things really start ramping up. So how do we know it's greenhouse gases? Well, scientists use, and myself included, use climate models to do that. So what I'm going to show here, I'm going to take a moment and navigate to a map, sorry, a graphic that's going to move around. But we'll start here. This is showing the observed temperatures on this line right here. And what you can see is starting right around here, this is about the mid-1900s, this is when things really start to ramp up. Now, scientists can run climate models and say, let's only run it with natural factors that affect climate that we know of. And then they can see the response out of the climate model and see how well that matches the observed record. So anytime the climate model's line matches this black line, then we'll know it's a good explanation for what's happening. So give me one moment while I stop share and move over to another screen. There we go. So this was data that was from NASA's Goddard Institute for Space Study, and Bloomberg visual artists and graphic artists put it together in this nice sequence of charts. So here's that observational graph that I just showed you. Now we move down and we can see, is it changes in Earth's orbit? So scientists have known for quite some time, several decades, that changes in Earth's orbit affect Earth's climate in a way that can induce an ice age. It can also bring us out of an ice age. However, this is something that happens on the scale of like 100,000 years. So over this short time span from 1880 to 2005, orbital changes have not had a big influence on our temperature. And you can see that it hovers right around that zero line, meaning the temperature is neither warmer than average or cooler than average due to these. It's very small change. What else could it be that are natural factors? Well, we have solar cycles. You might have heard of these. Solar cycles are changes in amount of energy that's coming out of the sun. It varies on several watts per meter squared, not too much. And we can see from that as well, it looks very similar to that orbital changes. About every 11 years or so, we will see a change in the output, but overall, it doesn't explain this warming trend that we're seeing. What about volcanoes? They emit a lot of CO2, right? Well, it turns out they don't emit nearly as much CO2 as we do, humans. Our factories, our cars, our energy production produces way more carbon dioxide, and specifically 100 times more carbon dioxide than volcanic activity. However, volcanoes do produce a lot of ash and sulfate aerosols, and these can block the sun and induce cooling. So these eruptions that you can see are dips right there. Bar. So that's Mount Pinatubo right there in the 1990s. And they're generally short-lived, usually a year or two, maybe 3 or 5 years at most. And then you return to baseline. So the volcanoes, they do have a very short-term cooling effect, but it does not persist. And it certainly doesn't explain the warming trend that we're seeing. So what if we combine all three of these things? Volcanoes, solar activity, orbital changes, certainly not matching that rise in temperature that we see since the 1960s, 70s. So let's move on to human factors now. Is it deforestation? Well, when we deforest a land surface, it actually turns out it makes things much brighter. So darker forests, when they're up like they are in New Hampshire and intact, are going to be absorbing a bit more of the sun's energy. But if we were to take all of the New England forest down, which we kind of did in the mid-1800s, that would actually make things much brighter, especially in wintertime when they collect snow. And this has a slight cooling effect, especially when you do it on the scale of like the Northern Hemisphere, when there was a lot of agricultural clearing in the mid-1800s. So it's not deforestation. What about ozone pollution? Ozone up high, so remember, good up high, bad nearby, the ozone layer does block UV light and cool things slightly. However, closer to Earth, it's actually something that can trap heat like a greenhouse gas, and that makes the climate a bit hotter. So the overall effect, well, it's not a huge component on the ground, so it really doesn't have a huge effect on warming the atmosphere near the Earth, atmosphere near the surface of the Earth. What about aerosol pollution? Aerosols you might have heard about. These are from usually coal burning. I had mentioned that in the moving map graphic. They offset warming. Unfortunately, they also cause acid rain. This was actually a phenomenon that was studied at Hubbard Brook in New Hampshire and uncovered in the scientific world. So it's not really a solution to climate change. One, because it causes acid rain, and two, you actually have to keep burning coal to do it. And that has another effect in terms of emitting the next human cause, which is greenhouse gases. So greenhouse gases from the burning of fossil fuels, well, this is mostly a no contest situation. Right now, what we see on this graph does match indeed that line. However, it's a bit overshoot. But recall that there were some factors that offset the warming. So when you combine all of those together, we now actually get a pretty good match with the observed record. What if we include all the factors? So now combining natural and human cause, now you even get the dips that are associated with volcanic eruptions. So it is indeed greenhouse gases that are explaining the rise in temperatures, especially over the last generation or two. So let's switch back to the PowerPoint now. Oops. Let's see what there is to see. Okay, so here's part of my journey, right? CO2 in the atmosphere has been measured at Mauna Loa Observatory since the late 1950s. It started right around 310-ish parts per million. And by the time I started skiing at Suicide 6, when I was probably about 7 or 8 years old, we were up to 351 parts per million. Within a couple years, Pat's Peak, when I started snowboarding, we were up to 360 parts per million. When I started graduate school at UNH in 2005, the number I had to remember for my exams was 380 parts per million. And then today, now that I teach at the University of New Hampshire, the number my students had to remember for their exam was 415 parts per million, and it keeps climbing. It's hard to imagine it going much farther, but that's where we're at. And probably within my children's lifetime, we will see much higher levels. We'll get to a little bit more detail on that as we go on. So what's this have to do with winter? Well, here's how winter's changed in the northeastern across the United States. And you'll notice that the Northeast is a winter warming hotspot. Over the past 4 or 5 decades, we've seen temperatures increase 3.5 up to 7 degrees Fahrenheit, which is a lot. For some regions, especially right around in the Pennsylvania, New Jersey area, this means that they've crossed the threshold from having below freezing temperatures to now having above freezing temperatures. This means that they have more rain coming, more winter precipitation coming as rain instead of snow. It means that the snow that does fall on the ground usually doesn't last as long as it used to. We documented this in a report recently. So we looked at over about 100 years of data from across the northern forests. So it was included much of New England. The report is available at Hubbard Brook. So if you wanted to take a look, you can take a gander at what we've uncovered. I'll summarize it here for you. Some of the key findings: 1, we're losing cold. Our sustained cold period is getting shorter. There are fewer days below freezing, and we have less frequent extreme cold days. So think less than 0 degrees Fahrenheit. We're also losing snow at the same time, which makes sense. If temperatures are warming, you're going to start losing a lot of the snow, and specifically the days with natural snow cover. Our winters in general are just overall shorter, and this is largely due to an earlier spring. So the onset of winter hasn't changed all that much, but it has gotten significantly earlier in terms of its end date. So what does this mean? Well, we were looking at climate. You might think, but it was just 77 degrees out. We also had a cold snap in September. So real quick, let's just talk about a little bit the difference between weather and climate. A short little video to show here.
A common mistake when interpreting statistics is to look at them from too short a distance. This can make everything unclear and confusing. So forget the details and take a step back. You're looking at a dog when you should be concentrating on the owner. As you can see, the dog is all over the place, leaping and bouncing, sometimes upwards, sometimes downwards. But where do you think it'll be in 10 seconds' time? Around here, right? But at this moment, the dog is on its way downwards. So why do you think it'll find itself up there? It's because you've noticed the owner. The owner is the trend, and it's he who determines where they both will be in a while as a bit longer than a couple of dog bounds. He could change direction. There's a lot we don't know about this guy, but everything we do know indicates he's heading in that direction. The owner is the long-term trend. The dog is the variation around this trend. Or the owner is the climate. The dog is the weather.
So that is a brief illustration and a fun little video to introduce the difference between climate and weather. Another person who you might be familiar with, Mark Twain, has a great way of stating it succinctly as well. What we're thinking about is climate is what you expect and weather is what you get. We expected the dog owner to continue on that straight path. The weather is where that dog ended up going, not the owner. When we think about what's happening scientifically, we could have new definitions. So weather is the actual state of the atmosphere at a particular time and location. You can also think of climate then as the statistical description of weather over a longer period of time. And this is typically decades or longer, 30 years or more. When we talk about climate normals, scientists are talking about a 30-year specific period. So speaking of weather, we noticed that Concord, New Hampshire, as of, that was November 8th, reached 75 degrees, and that broke the previous record that had been set in 1895 at 72 degrees. And you might have felt like, yeah, this is great. It's actually kind of nice to get a nice warm day in, one more shot of warmth. Other times, folks might feel a little like, this is kind of uneasy. It's November. I should be wearing my sweater and my jacket and my boots and not be out in shorts and a t-shirt. What we're experiencing is kind of a winter weather whiplash. So this is a change in what's happening with winter conditions either outside of winter or non-winter conditions inside of winter. This one up here is a particular event that was happening up in Vermont. I believe this also hit much of New Hampshire as well. And what you're seeing is a rain on snow on frozen ground flood event. So this one ended up with a lot of damage. These big white marshmallow things are not marshmallows. Those are hay bales that were floated off of a field nearby and came down the river. Now those are not exactly light. They're a couple 100 pounds. So moving one requires quite a bit of water to get going. We have names for all of these events that we documented in a recent paper that we published. And essentially what we're looking at is a false spring. So this is when things are rapidly warming in the middle of winter, enough so that buds come out, or maybe spring peepers emerge a little too early in March or in February sometimes. We could also have the rain on snow events. If you're getting rain, midwinter rain, this can lead to wet slab avalanches up in Tuckerman's Ravine, for example. We also have the snow on leaf events. This one was nearly happening a couple weeks ago when we had some snow come through, but fortunately it wasn't enough. But when it falls on leaves, it can do a lot of damage. We also have winter heat waves, and these are my least favorite. This is one that my friend Alex took at one of our field sites, and it was 75 degrees in February. That was a particularly tough day to be trying to measure snow. Now they have impacts, not just on humans, but also on different things like up at Hubbard Brook, we were looking at Streamflow. So this is actually an example of their ice storm experiment, but just this is more an event that we were studying in Hubbard Brook, specifically related to Streamflow. We had found that during those winter heat waves, when things get up to above 64 degrees and then return back to normal conditions, the streams are responding by having the stream flow increase 5 times above what their base flow is. So if you have roads, these can be damaged during these types of events. Culverts can be washed out and such. We also have the rain on snow events, which have an even bigger impact. Stream flow during these events increased on the order of magnitude. So instead of 1,000 cubic square feet per minute, it would be up to 10,000. So think of like an order of magnitude as being that compared to the winter blaze flow. So very, very damaging when we see these. And unfortunately, both rain on snow events and winter heat waves are expected to increase in frequency in a warming climate. So this map is showing one of those winter heat waves. You can see up into New Hampshire, we were well into the 70s. This was this particular event that happened in February 2017. So this is another event that hit that weather station that we were running over in Durham, New Hampshire. So how do scientists know that they're going to increase in the future? Well, I talked a little bit about climate models and how we can use them to do fingerprinting to understand, like, is it greenhouse gases? Is it volcanoes? We can also use them to project into the future and determine what climate's going to be like. One of these models I've shown here, this is kind of a schematic for your basic global atmospheric model where it has horizontal grids, so you're breaking up the Earth's surface into squares. And then you have vertical grids, which are usually atmospheric height or pressure. And sometimes these go down into the ocean as well. And they're representing different physical processes that we can explain using physics or biology, such as photosynthesis or heat transport. Climate models started off relatively simple. The first ones were developed in the 1890s, and all they had was radiative transfer. It's basically energy comes in from the sun, goes through a layer in the atmosphere, and goes back to space. And how much does the temperature change based on how much greenhouse gases are in the atmosphere? In the 1960s, they started adding nonlinear fluid dynamics, and the atmosphere could move around. The hydrological cycle was added in. In the 1970s, sea ice and land surfaces were a big component that were added. The previous 1960s models were more like aquaplanets. In the 1990s, atmospheric chemistry started coming in vogue. And then in the 2000s and into the 2010s, we started looking at aerosols and vegetation, biogeochemical cycles, and carbon cycling. So they've gotten much more complex over time. The resolution has also gotten a lot better. If you're looking up at the top grid up here, this is kind of like playing 8-bit Super Mario, very early on video games. And as you get towards present day, they're now running them regularly at 110 kilometers, which is still relatively coarse when you try to think about like, what's 110 kilometers from me? Do they have the same climate as me? And I think about, what's north of me. They probably have a colder climate. They probably still get a lot more snow than I do. So the resolution has gotten finer, and it's still getting finer and finer every day. But now you can finally tell at least that this is Europe. Whereas in the first one, it's really hard to tell what even continent we're simulating there. If you've never seen the guts of a climate model and wondered what they look like, tonight's your lucky night. I'm going to show you some example of code that is developed through, this is for the National Center for Atmospheric Research, and they call it the Community Earth System Model. If you really wanted to dig into the code and you're into that type of thing, I do have the website here. This will be available after the recording, but it's all publicly open source and shared. Anyone can run the model if they have the computer know-how on how to do that. And they're welcome to look at the code as well. So let's see, what does it look like? That's it. It's actually written in Fortran. It's an ancient language that was developed in the 1950s and is still used today. So we have this one particular section of code is showing how snow ages over time and changes its grain size. So as snow ages, the grains get bigger and it becomes less reflective. And that's essentially what this one module is doing. And there are hundreds to thousands of modules within climate models that are all working together through a central coupler to produce future changes in climate. Now, the forcings that we apply to that climate model are going to determine the outcome in the future. So we can tell the climate model, here is what global carbon emissions are going to look like under, say, a Paris Agreement scenario, right? So we can see the emissions decrease out to 2100, and you can see a change in temperature associated with that out of the model. So you would limit the warming to about 2 to 2.5 degrees Fahrenheit above what you see in the early part of the 1900s to 1950s. What about other scenarios? Well, if we continue to have emissions increase, maybe they'll plateau around 2050, and then they'll decrease and stabilize by the end of the century. This is another type of scenario that we could run with the climate model and see that the temperature then stabilizes about 4 degrees Fahrenheit above what we saw in the 1900 to 1950 period. For reference, right now we're already about 1.8 degrees Fahrenheit above this level. And so that means we would have another 2 to 2.5 degrees to go before we'd be stabilizing. You can see it's kind of leveling out there, might go a little bit higher. We also have this higher scenario, unmitigated warming, when we continue to burn fossil fuels, we don't embrace energy efficiency, and we let global emissions climb to over almost 30 gigatons of carbon. This means that global temperatures could probably exceed 8 degrees Fahrenheit above average, so more than quadruple than what we've already seen in our lifetime. So, poll time. Which scenario are we currently following? So I'm going to start the poll. Poll. Launch poll. All right, so I'll give you a couple seconds to answer this one. Are we following that higher scenario, the lower scenario, or the Paris Agreement scenario? So I got some answers coming in. Looks like we are starting to plateau. Okay, I will end the poll. If you guessed higher scenario, you'd be correct. I guess the silver lining on this is that that higher scenario that I showed you would actually be unrealistic based on where coal is going right now. So that scenario is based on coal usage expanding to 6 times what it is now. And as we all, if you've been following the news, you've probably noted that coal production and coal consumption is actually on the decline. So it's unlikely that we'll get to that level, at least with burning coal. There may be other paths that could bring us to that type of warming. So very important that we reduce carbon emissions. Okay, so I will close the poll. So what does that mean for New England and the northeastern United States? Well, my colleagues and I recently ran a model. This is my friend Daniel Grogan led this paper with myself and Alex Contesta. We're all at University of New Hampshire. And we just published this paper in Environmental Research Letters. And one thing we were looking at is, when does the snow disappear? So shown here, this is from 1980 to 2005. So think of this as the historical record. You can see that most of the places at high elevations, it's well into May before the snow disappears, and sometimes even beyond that. If you're in the seacoast region, probably closer to mid-March, late April in the 1980s. You can certainly see other mountain ranges in here. The Adirondacks pop out, White Mountains, the Green Mountains, and anywhere that's coastal and more southerly tends to see the snow disappear earlier. So what happens as we move forward in time? Well, under the lower climate scenario, by the end of the century, so think the last 30 years, 2070 to 2099, we're going to see the snowpack disappear on average across this region around March 29th. Note that some of these regions, like Southern Connecticut, New Jersey, Pennsylvania, they actually don't even have snow anymore, right? So I can toggle back and forth. That's the historical, that's in the future. So some of these regions are going to lose their snowpack. So April 13th to March 29th, we're looking at 2 to 3 weeks less snow in terms of the end of the season. Under the higher scenario, it looks like my days as a climate scientist, or at least a snow scientist, would be numbered in this region. I should probably be moving north if I want to continue studying snow. So this region in the seacoast certainly doesn't have any more than maybe a couple weeks of snow at best. It wasn't enough for us to calculate a snow disappearance date. The good news is that the higher elevations, Mount Washington, Mount Katahdin, up in the White Mountains and the Appalachians there, we are certainly still going to have snow, which is great. I would hate to see all of it disappear, but it's going to be disappearing earlier in the year. So that could mean maybe we'll have more spring skiing conditions. I like to try and keep a positive attitude, but it also could mean further south, maybe there's more spring biking. People get on their bikes a little bit earlier, head outdoors for hiking and other activities that they typically don't do nearly as much in winter. Could that also mean for our region that there's fewer skier visits overall? Scientists who have been sociologists studying this actually find that skiers might be not as proportional, they wouldn't decrease proportional to the amount of snow we're losing. Instead, they might congregate more at the mountains that do continue to receive snow. So the further north you are, the higher elevation you are, the more likely that you'll be able to pick up the skier visits that other mountains that are further south and not at high elevations, if they don't make it, you might be able to pick up their market share. That's kind of where that's at. This picture in particular was taken on Christmas Day, and you can see they're furiously making snow up at the top of the mountain, but the bottom of the mountain was lacking from Mother Nature for sure, and it wasn't quite cold enough to make it worth it to make snow down there. So we studied this quite a bit, also at UNH. This is a paper I published, or report I published in 2012, looking at the economic impacts of warming winters on skiing and snowboarding and snowmobiling. And we updated that report recently in 2018. So I'll tell you a little bit about the findings we found from these reports and how warming winters are probably just not good for the economy. So specifically, this was a snapshot of 2015, 2016. Anyone who was skiing in New Hampshire in that winter might remember that as being a bit of a bust. So it's probably one of the worst seasons that we had seen in quite some time. Maybe 2012 would have been a bit worse than this one. I can't remember exactly how those two ranked out, but it was challenging. But the spending that we do see is about $11.3 billion across the United States. And we see about 191,000 jobs supported by the ski industry. So 11.3 billion, that means not just the money that's spent at the resort, that'd be the direct spending. So this is buying your lift ticket. This is maybe buying lunch at the lodge. But it also includes the indirect spending. So this is spending, maybe you stayed at a hotel that was not on the resort property. Maybe you rented an Airbnb. Maybe you rented equipment while you were there. That money in turn that you spend at those other places, so restaurants within, say, North Conway, gets spent by the people who work there. So they're paying for childcare, they're paying for transportation, they're paying for their own groceries and food. So that 11.3 billion is essentially how much is the money circulating within these economies that is derived from the ski industry being there. So it's quite a bit on the line. We can also look at this by state. So keeping in mind 2015-16, not a great year in the Northeast. You could probably inflate these numbers by at least 25% in a good year. So take that 5,721 jobs supported in New Hampshire with a little bit of grain of salt, because that means that during a good year, it's probably a bit higher than that. Clearly, Colorado leading the nation, well known for their high elevation and plenty of snow, 43,000 jobs supported there. And then also in California, 21,000 jobs would be a second place. If you add them all up, again, in a good year, New England and Northeast in general can compete pretty well with Colorado. We have quite a bit of skiers. We also have large metropolitan areas from which to draw skiers as well. What about that economic activity? Well, when you take a look at New Hampshire, it's hundreds of millions of dollars. And the vast majority, almost 50%, of our visitor spending in the North Country is coming from winter recreation and winter tourism. So it's a very important part of our northern economy. Excuse me one second. Out in Colorado, snow is worth a lot of money. $2.5 billion is supported by the ski industry. Colorado actually has more people employed in outdoor recreation than they do in the extractive industries like oil, gas, and minerals, which is kind of amazing when you think about it. It's a big business out there and tourism is huge. So keeping that in mind, it's important to save those types of jobs for people that work in those states. So we also took a look at what impact warm winters had and cold winters had on employment and that economic activity. So relative to the 2001-2016 average, so keep in mind, this is well within the era of snowmaking. Many resorts do this in the Northeastern United States. There's very few that don't. And the resorts that do are usually covering over 90% of their mountain with it in order to make sure that they can stay open and open early for skiers around Christmas time. So those top 5 years add an additional 692 million on top of that 11.1 billion average that we saw. And when you're thinking about jobs, they support about 11,800 more jobs in good years compared to average years. When we look at the years that are not so nice, it can be a devastating year. Now we see a decrease of about, on average, $1 billion relative to our long-term average, and 17,400 fewer jobs. So why aren't these equal and opposite? Well, when you have a good year, you can reach capacity, right? You can only move so many people up the lift. You can only park so many cars in the parking lot. And that means there's an upper limit to how many people you can get on the mountain. When you look at the bottom years, though, you can actually end up with years where the mountain simply doesn't open. And this happened in Oregon. This was Mount Ashland was trying to celebrate their 50th anniversary. I always forget if it's 2014 or 15. But unfortunately, that year was so devastating for them that they couldn't open the mountain. They couldn't even make snow. So those years are the ones where things can really drop off. So do winter sports enthusiasts recognize this warming? I had a hypothesis that maybe they would. They spend a lot of time outside. They have a lot of money invested in the sport. And maybe they would recognize when big changes are happening in their surroundings. So I did what any scientist would do. I called a sociologist, and they helped me ask 1,200 residents in New Hampshire which of the following statements they thought was more accurate. So in New Hampshire, winter temperatures over the past 20 years, have they been cooler than the last 30 or 40 years, about the same, or warmer than the last 30 to 40 years? So I was hoping maybe skiers and riders would understand that maybe, yeah, that winters are been warmer. It's an answerable question, right? If you look at New Hampshire specific temperatures, this is the red line is the 10-year mean. And looking at the blue line, that's the average from winter to winter. So it's very clear the last 20 years have indeed been warmer than the last 30 to 40 years. So what did we see in terms of the percentage of people who answered correctly? Well, only 38% recognized that winters are warmer today than they were 30 to 40 years ago. And I was quite surprised. This is far less than half of New Hampshire residents could accurately understand that winters are warmer today. Remember, I had a hypothesis about whether they participated in sports. So we also asked them if they frequently, occasionally, or occasionally, but not in the most recent year, 5 winters, or in the last 5 years, asked them if they participate in any winter sports: skiing, snowboarding, snowshoeing, ice fishing, snowmobiling, hiking even. Again, 43%, so just under half of people in New Hampshire participate in some sort of winter sport. So we have a pretty decent sample size to answer this question. But, well, what we found, anywhere you're seeing this p-value, it's essentially looking for a statistical significance. Didn't matter their age, their sex, their education, or their participation in winter sports. It was not linked to correctly understanding that winters were warming. None of those factors could explain it. However, recognition of winter warming is linked to their beliefs in climate change. So if they were more likely to believe that climate change is caused by humans, they were more likely to recognize that winters are warmer. And it's also linked to political ideology. Liberal, moderate-leaning folks are more likely to correctly acknowledge recent winter warming than folks that are conservative or leaning right. And this has been proven in so many studies. This is just one small study in New Hampshire. Larry Hamilton, my co-author, has done numerous ones of these in New Hampshire, and the same pattern always emerges. It is a very much political issue, and it's unfortunate that scientific facts are tied to these political ideologies. But that's where we're working with, and that's where we have to move from. So the key findings of this report: fewer than half of New Hampshire residents were aware of the winter warming. Awareness of warming was no higher among people who participated in winter sports, nor were there any significant differences by age, sex, or education. And the awareness of warming most closely responds to their political identity. So what do we do about this? Well, for the past decade now, I guess it's been almost a decade, I've been working with an organization called Protect Our Winters. This is the founder of Protect Our Winters, Jeremy Jones. I was up in Alaska working on drilling an ice core with a team from Dartmouth and UNH and UMaine. And of course he was coming to ski because he's a professional snowboarder. And we happened to be chatting there. And we have been talking a little bit about these global warming's 6 Americas. Have you guys heard of this? If you haven't, I'll just briefly introduce. Most Americans can fall into one of 6 categories when it comes to climate change. They could be alarmed. That would be me. I'm a climate scientist, and I study this all day, and I'm very alarmed with what I see from work that's coming out of my colleagues' labs. They could be concerned, cautious, like maybe something's going on, disengaged, we just simply don't care one way or the other, doubtful, or dismissive. Dismissive is also known as climate deniers. So this is the category of folks that simply do not believe anything is happening that's related to humans, nor is it warming. The good news is that the dismissives have decreased by about 5% since the Yale Climate Change Communication Program started this type of survey. So since 2015, over the past 5 years, we have seen a 5% decrease in the folks that are most likely to deny the existence of climate change. The other good news is that the alarmed folks have increased substantially, 26%. Oh, sorry, 50, yeah, sorry, they've increased to 26%, which is huge. That means that it's awareness of this issue and the impact it has on humans and ecosystems and society is increasing. Now, this is just for America. Clearly, there's a lot more going on in the world, and, and we would all need to work together to this because we're all on the same planet. We also know that there are certain demographics of folks that are more likely to fall in one category or another. Specifically, Hispanic and Latino folks are much more likely to be alarmed and much less likely to be doubtful, dismissive, or disengaged. In fact, the largest portion of people that are going to be dismissive, doubtful, or disengaged are white people. You also might recognize that skiers and riders also tend to be white people. About 75 to 80% of skiers tend to be white. This can be something that serves as a talking point. If we know who needs to be moved on the dial and who needs to understand that this is a problem, moving folks from these categories to cautious, concerned, or even alarmed is going to be a top priority. So the winter sports community is getting very political. Protect Our Winters, again, there's the co-founder, Jeremy Jones, he's a professional rider. This is Auden Schindler, he works at Aspen as their sustainability coordinator. Gretchen Bleeler is a professional Olympic snowboarder. And then Chris Davenport, who's from New Hampshire, is also an Olympic and big time skier. And they go to Congress regularly to lobby for any policies that are going to move the dial on climate change, which I think is probably one of the most important things you can do. Resorts are also taking action. Many of them are reducing emissions and they're increasing energy efficiency. Breckenridge here has committed to 100% renewable energy. I believe it's by 2025, maybe it was 2032. Salt Lake City, Truckee, California, Burlington, Vermont. Many of these towns are associated with winter sports or they host a large resort to begin with. So they're starting to walk the walk. Now in New Hampshire, we have another poll coming up. Our last poll. What are the 5 towns in New Hampshire, or sorry, which of these New Hampshire towns have committed to 100% renewable energy? So take your pick. Which ones do you think have done this? And I'll give you a hint. None of the town, or sorry, there are no missing towns on there. So if you're thinking of a town and it's not on that list, that means they have not committed to 100% renewable yet. Still see answers coming in, so let it keep going. One more second. See, there's a surprising results. I'm very interested in this. Okay. I see things leveling off, so I will end the poll and share the results. Okay, so there's actually 5 on this list that have committed to 100% renewable. And they are Hanover, which was one of the first, Cornish, Plainfield, Concord, and most recently, Keene. Many of you, well over 50%, selected North Conway, but they have not committed to 100% renewable yet. It is my goal to see that they do, not just their town, every town in New Hampshire. What I like about the way this works is that many of the towns that have committed to this are now laying out the blueprint and the plans for how a town can do it. So if a town like Hanover, which supports a large university, can do it, maybe they can share that information with other towns. Same with Concord. It's not a huge city, but it's a sizable one. It hosts the capital. Cornish, a relatively small town. Plainfield as well. They also have plans to do this. North Conway, where does that fit in? Who could they learn from to get their plan moving forward to commit to 100% renewable? Okay, so we'll stop sharing the poll. Keep going. What else are they doing? Oh, those are the 5 towns. Yeah. So state capital was one of them. Forgot I added that slide. Resorts are also bringing science to the mountain. It turns out it's really not hard to get scientists up to the mountain. This one features scientists from CU Boulder. This is at Arapahoe Basin. And they weren't sure how, this was one of the first events that Protect Our Winters hosted, doing these Science at the Mountains events. And they weren't sure how many people were going to show up. So they planned it in the conference room and it was packed. They were like, okay, so next time we'll do this kind of après-ski style. Maybe do it in the bar instead. Definitely get a lot more of the audience involved. Scientists really love skiing and riding. I know so many scientists who like being up at mountains and are happy to talk with anyone about the work that they do. Right now in this photo, this is the entire, not the entire, but a good chunk of the Climate and Global Dynamics Division at the National Center for Atmospheric Research. And we were taking a day as a crew to go skiing up at Arapahoe Basin. This is me over here in the yellow coat, the only snowboarder that trip. Some resorts are also snow farming. This is an alpine glacier that is melting, and the ski resort put a tarp over it to preserve the snow into the next season. This is a specific situation where this works because they're actually on a glacier and they're able to preserve it for the next year. Other resorts are putting sawdust, layers of sawdust over piles of snow so that they have a base to work with when they start making snow the next season. Speaking of snowmaking, it's gotten so much more efficient. They use much less water and much less energy, can cover so much more acreage in a much shorter period of time, as long as you have the water. So this isn't as much of an issue out in the eastern United States. However, in the western United States, things get really complicated, especially when you're talking about water rights and how much water allotments you get for that purpose. This one actually is, you might notice these folks are not downhill skiing. This is one of the largest Nordic races in the United States, the American Birkie, and it was canceled in 2017 due to poor trail conditions. They didn't have enough snow and they had to call it quits that year. And now a lot of these resorts that are Nordic skiing resorts are actually thinking about like, okay, I guess we have to do snowmaking as well. And they do. Snowmobiling becomes a lot more challenging though. You have many more miles of trails and it would be very logistically impossible to probably try and do that. Resorts, I'd also mentioned the half marathon at Suicide 6. I'd also gone to a wedding at Pat's Peak. Many of the resorts are realizing like they have the facilities to do year-round activities, including conferences, weddings, reunions, get disc golf. It's certainly not a huge part of their bottom line. For many resorts, it tends to be less than 15%, but it seems to be that a lot of them are moving in that direction. And for some resorts, it can be a huge part of their revenue stream, especially if they're doing big summer concert festivals, which can bring in quite a bit of money. So what can you do? We want to end this on like an empowering note. You can educate yourself, defend the science, vote, walk the walk, measure snow, and of course, talk about climate change. So I'll go through each of those just really quickly. If you're wanting to know much more about climate change, I know I gave a really brief intro at the beginning. You can definitely go to climate.nasa.gov, and they have excellent data on there and excellent explanations about climate change. There's numerous other places that you can go, but I definitely go reputable expert sources like NASA. You can also defend the science. A skeptic will question the claims and then embrace the evidence, and a denier or a dismissive will question the claims but then reject the evidence. So if you see someone that's rejecting evidence that's put right before their eyes, it's unlikely you're going to sway them. But if it's someone who's cautious or maybe concerned about climate change or unsure, then you can defend the science, point them to resources, and help them understand where things are going. I did put skeptical science down there. They've got a great list of popular global warming myths. So if someone's trying to say like, oh, it's solar cycles, you can go to skeptical science and they can explain to you very briefly why that is a myth and why it's not solar cycles. I know we had kind of talked about it in the beginning. I'm going to skip that part for now. You can also use your voice. We know this is a political issue. It's important to speak up and get political. and vote. Catherine Hayhoe's a brilliant scientist down at Texas Tech University. I've done several reports with her. And she has a famous quote that a thermometer is neither Democrat nor Republican. And it's true. Thermometers are just recording the data as it comes in. And speaking up doesn't have to be always voting for, say, Democrats or for liberals or for progressives. It can also mean, if you're right-leaning folks, that you talk to your representatives that are you agree with other policies perhaps, and say that this is important to you, that you want to see climate action on their agenda as well. It can be a bipartisan issue. It doesn't have to be partisan. Also walk the walk. I noticed when I was a couple of years ago, my carbon footprint was getting quite large because of conference travel. So I started reducing my energy and fuel consumption, reducing the number of flights I had to take. I can carbon cap or tax myself. So say if I know my carbon footprint, I can say I'm only going to emit this much carbon this year and try and set myself on that. You can also support the low carbon economy. Local economies are much more have a much lower carbon footprint than ordering a lot of stuff from far away in the country or from overseas even. So I try to reduce the amount of stuff that I'm buying from far away that has to travel far to get to me. The last thing we just did, we just bought our own house, our first house. That was last, I guess it was 2 Marches ago. And we started because our house is heated by electric heat and a wood stove. And you might know, if you live in New Hampshire, electric heat is really, really expensive. So we contacted the New Hampshire Saves program. And this one's a program specific to New Hampshire. You probably, if you're from another state, you could probably find similar programs, but they offer amazing rebates and credits for improving the efficiency of your house. So it's included a lot of insulation that we redid, and we saved about $70 per month on our electric bill by doing this program. So check it out if you're thinking of renovations or thinking of reducing your electric bill. They have heat pump rebates and a whole bunch of other stuff. So definitely give it a shot. We also measure snow. This is something I do for my job, but you can also do this in your own backyard. The Community Collaborative Rain, Hail, and Snow Network buy about $30 rain gauge, which is shown here down in the middle, and you can measure snow. And this data will go to hydrological forecasters and weather forecasters to help improve their forecasts and their models. We also have, if you're a backcountry enthusiast and like to hike the trails in New Hampshire, bring a snow probe with you. Avalanche snow probes are one of the best measurement devices that you can have with you, not just for safety, but also for measuring snow and reporting it to community snow obs. You can also, last one. I'm going to end on the most important thing you can do to fight climate change, and it's something I do quite frequently, is to talk about it. If you haven't seen it yet, look up Catherine Hayhoe's talk. This is the exact title of it. And she will walk you through why it is so important to simply talk about climate change. I have to do this with friends and family and explain to them what I do for my job. And sometimes this can be politically charged, and other times it can be very productive because we usually find something to connect on. For me, a lot of the conversations I have with folks connects on skiing and our love of snow and winter. And that provides a starting point. From there, you can talk about ways to preserve those things that you both love. And with that, I do want to leave a little bit of time for questions, so I'm happy to stick around. My name is up there at the top with contact information. You could also check out protectourwinters.org, and of course, some funding agencies that help support my work as well. So with that, I will stop share. There we go.
Thanks, Liz. That was excellent. I really appreciate you taking the time to move through that. Been fortunate enough that Liz has spoken for the observatory in the past, and great to see. I know your work is updated all the time, so certainly we appreciate you bringing that today. As Liz mentioned, now is the time for questions. We have already a good number of them in there right now. We're going to get to as many as we can while we have Liz's time. Again, if you'd like to ask a question on Zoom, just hover down to the bottom of your screen there and you'll see the Q&A button. So please put that through there. A lot of great questions so far. I've really been enjoying seeing these come through. Let's go to one that came up a little bit earlier on that I know you touched on a bit in your discussion between weather and climate. But Catherine asks, in addition to a gradual increase in average temperature, aren't we also seeing a comparable relative increase in variability? So are we seeing more variability in our temperature as well?
One way of thinking about this, yes, is that we are seeing many more of these extreme events popping up, and especially the extreme hot records. So, record warmth is certainly outpacing record cold. And it's the ratio is about 3 to 1. So, for every three record warm temperatures we are seeing probably one record cold temperature. It's not that they don't happen, they just happen much less frequently. So the winter weather whiplash work that we are working on is certainly analyzing this. Like, are things getting more variable? And it's a tough question to ask. I mean, it's hard to say that we were ever in really much of a stable climate. Weather is always going to be present. But definitely in the future, we are going to be seeing these strange warm events that are certainly out of season, like today.
Yeah, and kind of following on the heels of that, Alexander asked a really interesting question that kind of gets at some of that winter weather, the weather and sort of the longer term variability and also some of the climate variability as well. But so Alexander asked, overlaid with the long term trends of climate change and global warming, the winter weather in New England is also significantly influenced by global weather cycles like El Nino and La Nina, and also the exact position of the jet stream, its influence on the polar vortex, all those things. So can you talk a little bit more about these effects and their influence on our winters and sort of that shorter term? And do you have any updates perhaps on winter 2021?
I wish I could say that I know exactly how winter 2021 is going to unfold. Unfortunately, I have low confidence in predictability of winter weather in New England based on El Nino La Nina. We are very far removed from the center of action, which is in the central Pacific. So places like California, Colorado, Western United States, they have a much stronger relationship. So when they see a La Nina, they know it's going to be a drier or a wetter year, or vice versa with El Nino. They up in New Hampshire, it's much more an interplay between El Nino and, say, the North Atlantic Oscillation or the Arctic Oscillation. You need those two things interacting. And when you have something like the NAO that's changing on weekly to a biweekly schedule, it's nearly impossible to predict that. And I know Judah Cohen, though. He's a very brilliant man. He works for AER down in Massachusetts. He works on a forecast. So if you want to check out someone who really digs into the data and has an excellent like discussion of the different features that are popping up, check out his work. So Judah, Judah, Cohen, Cohen. He has his winter forecast that he puts out every year. I haven't checked his yet because I think it's too early. I like to check closer towards the end of November into December.
Yeah, they'll be coming out soon, including NOAA's long-term forecast. And in fact, good plug for our January program. We're going to have a meteorologist from the Gray Maine National Weather Service office come in and actually do a little check-in to see how some of those comparisons did and talk a little bit more about long-term weather prediction. So if any of that stuff like NAO or anything else Liz just said sounded a little bit like gibberish, don't worry. Hopefully Derek will come in January and straighten us all out on that a little bit.
Those
All
are
right, so
in of themselves, yeah.
yeah, interesting question here. This is more to do with wildlife, I suppose, but a good climate connection. Ken and Jane ask, what effect will warmer winters have on ticks? Do you know?
Yeah, so ticks have a very complex relationship with winter temperatures. It's not as straightforward as ticks go up when it's warmer and ticks go down when it's colder. They're definitely beholden to their hosts as well. So small rodents, um, deer, moose, all of those ecological habitat or ecosystems are interacting to produce them. The general consensus, though, is that tick habitat does expand when you have warmer winters. And some of this gets very complicated. I'm not a moose or a deer or a mouse biologist, but I know there are scientists out there that do study this. So I would recommend touching in with that. But the bottom line is that warmer winters are not, it's not great for us in terms of ticks. Probably good for ticks themselves, though.
Unfortunately, I'm sure
Yeah.
there's not many people pleased to hear that answer.
Yeah, and this is also true of many other pests that have otherwise been kept at bay because of cold winter temperatures. So emerald ash borer, for example, and the hemlock woolly adelgid that's affecting hemlocks. All of those are kept at bay with some relationship to winter temperature.
Oh, interesting. Question here from Eric about coal and coal consumption. Obviously, you made reference to the U.S. and sort of the decrease in the amount of coal and coal production happening at the moment. But what about places like China and elsewhere in this global system in which they're still using quite a bit of coal?
They are, but the overall global trend is we are not going to see an increase in 6 times what we're seeing today in coal production. It will change, but right now the economics behind coal are not favoring expansion of coal, either in China, in Japan, or sorry, China, India, or in the US. It's just on its way out. And I think that's a good silver lining to all of this. Renewables are also getting a lot cheaper. It wouldn't make sense to continue building coal plants in the face of much cheaper and affordable renewable energy options.
Yeah, and on that, I know there's a question in here. Apologies if I forget this person's name because I can't find the question. Someone was asking about, I mean, what role does nuclear energy play in here, and what are some of the benefits and downsides that you can think of when you think of nuclear energy?
Yeah, I mean, it's not my top pick. My top picks would be solar and wind. I know right now New Hampshire's predominant source of energy does come from the nuclear power plant in Seabrook, New Hampshire. I also know that Seabrook is vulnerable to sea level rise. The area surrounding it, the plant itself is above sea level and probably wouldn't be affected. But there are parts of it that where cement is getting brine intrusions, I believe it was. I'd have to look this one up again, but I remember looking into it and being like, there's probably better options here. Dealing with nuclear waste, especially on coasts. We saw what happened in Fukushima, Daiichi. That was a terrible situation. We don't have to worry about earthquakes here, but many other regions that host nuclear power plants do have to contend with sea level rise.
Yeah, definitely some big, especially long-term challenges there, and even the shorter term scenarios you mentioned as well, a little bit scary.
Mhm.
Um, Question from Jessica. She asks, or she says at first, our family has stopped buying season tickets because of poor conditions. I'm guessing she's referring to skiing or riding.
Mm.
Have any studies shown a decrease in the number of skiers and riders in New England? Are less people going out?
Yes, this one's a tricky one. So there's skier visits, right, which is the number of people that come and either stay for a day or a half day at a resort. So I might have, say, like 5 skier visits under my belt by the end of the season or something like that. There's also participation. So are you someone who skis at least once per year? And those two numbers don't always agree because there could be some folks that get in many skier visits and contribute to those large skier visit numbers. But the number of people participating in general has kind of plateaued, and if not a little decrease across the United States. Within New Hampshire, I'm not 100% sure. I would check with New Hampshire, Ski New Hampshire. They might have those numbers directly. But overall, the winter of 2012 was a huge hit. That was a big dip. And I wouldn't be surprised if this person who asked the question, maybe that was the year that did it for him. Maybe that was the year where they said, you know what, maybe I'm not going to buy a season pass next year. We also have to acknowledge that folks do go through life cycle of skiing. I'm currently in the small children life cycle of skiing. So getting out is really tough. I have a 9-month old now and a 6-year old. 6-year old's rear and ready to go. The baby, on the other hand, it's going to take a little bit more to get out there, and it's expensive as well. So you kind of have to like contend with this cycle in your life. This is Larry Hamilton was the one who raised this point. I was like, man, I never go skiing anymore. He's like, you're in that part of the life cycle. Don't worry about it. It'll come back. And it's true. I mean, like eventually I will get back out there, but when the prices are as expensive as they are, I could see why folks would be hesitant to invest that type of money. I haven't seen an exact trend on the season passes, but I'd be curious. I wouldn't be surprised if there's been either a plateau or a slight decline.
Yeah, that makes sense. And as you mentioned, certainly a few other considerations to manage throughout your enjoyment
Yeah.
of getting outside in the winter. This is a really interesting question from Marie, in which I think I want to jump right on this because she asked, is it possible to query the voter demographics of the attendees in this program, liberal versus conservative? Is this event more of an echo chamber or spreading the climate change message. And I did actually load a poll up here, so I kind of want to see what this is gonna turn up. You don't have to participate if you don't want to. I mean, this is anonymous anyways, but I'm kind of curious. And Liz, I don't know if maybe to expand on that, do you find yourself, I mean, who are the audiences that you're usually speaking to?
Oh, this is an excellent question. And it fascinates me too, because of working
Here
with
it is. Here's the
sociologists.
poll.
Yeah. Ah, yeah, we'll see.
I don't know. These are the
Yeah.
best categories I can come up with on a whim here. So
Yeah. Well, no, so
excuse me.
actually we have polled skiers and asked them about their political leanings, and it's really 50-50. Like their skiers are neither left nor right nor center. They span the whole spectrum. And that's, I mean, that's pretty, I would say, consistent with what I've seen and people I know who ski. In terms of like echo chamber, this is a big problem. And that's kind of why I concluded with the last slide. You have to talk about climate change with folks who may not agree with you. And it needs to be a conversation starter, not an ender. It can be a tough conversation, but it's much needed. I also, you know, finding those shared values is easy enough. There are folks that they like hunting and they like fishing, and all of those are impacted by climate change. Okay, so this is actually, yeah, we've got 10 folks here. So welcome 10 folks that are leaning conservative or conservative. We have a good fair amount of moderate. I mean, I'm a registered independent here in New Hampshire. So I would say I fall in that category. And then certainly a higher proportion of liberal, which doesn't surprise me. If you're carving time out of your day to learn about climate change, that might be part of it, is that you seek these types of programs out, whereas otherwise maybe it's just something you happen to on. That's a great
Yeah,
question.
it was a great question. Thank you, Marie, for that inspiration. You kind of got it. I mean, in talking a little bit more about, your job, what you get into, who you're talking to. Great question from Jen. What's your favorite part of your job?
The first snow of the season. No, definitely getting outside and measuring snow is the highlight of my year. And it comes with the negative side, but the worst part of my job is going out and measuring snow when there is none. So we also measure soil frost depth. So I still go out in the field and we'll measure those things. Also measuring snow when it's just pouring rain. I don't miss a measurement. We go out every day unless it's unsafe driving conditions. But it's, it comes with the best part of my job is also the worst part of my job, which is measuring snow.
Yeah, sad moments. I know when I go to our co-op station as well. It's when it's raining in the winter, not so fun.
Yeah.
All right, let's see. Let's see if we can get just a few more here. One is probably a little more Mount Washington specific question. See, Liz, what you might know about this. But Susan asked, what do you think the future will be for the Alpine Garden specifically on Mount Washington? I don't know if you can answer that maybe in a more general sense.
I've been to the Alpine Garden maybe once, and I think I might have been in fourth grade. So it's been a while since I've been up there. I do know there are folks that are studying this. So I think, are they at Krell, or is it folks just at Mount Washington? I think they
Yep.
were. Yeah, you might. I think you
Yep,
would.
and the Appalachian Mountain Club. Yeah, I won't steal the
Yeah.
show here, but my best answer for that one, um, there's an interesting dynamic that's happening up and down the mountain on Mount Washington. A recent study, in fact, an update on some longer term studies here, including with partners over at the Appalachian Mountain Club, have found that the summit of Mount Washington is warming, not at the same rate as even just below down at the base at Pinkham Notch. And there are some interesting ideas given Mount Washington's prominence and exposure to the planetary boundary layer, perhaps being the major impact there. For the moment, my understanding with the AMC and the studies they've done around alpine ecology, the blooming times for the plants there in the alpine garden and above tree line, that limited area that we have in the Northeast, certainly it's a slightly longer growing season, which is same thing that's happening down below, but quite a bit longer at lower elevation. So interesting question, and certainly an area that needs more study.
Yeah.
And let's see, let's see if I can get you just a couple more here. Thanks so much for sticking around,
Yeah, no problem.
and everyone else who's stuck around to ask lots of great questions. Hank wants to know, where do you measure the snow? Because you mentioned you measure snow all over the place.
Yeah, no, I measure most of the snow I measure is in the seacoast. So I measure snow at the Thompson Farm Research Farm and other UNH properties. We had at most 3 sites, no, 4 sites going. I think this year we're going to reduce it to 2 due to COVID. It's harder to get students out there measuring and make sure that they have enough time to do that. And we just want to maintain safety while we're doing it as well. I know last year we were trying to measure snow in Thompson Farm and we were using UAVs. So we were measuring with LiDAR. And we actually had to send folks up north to find snow because it was such a terrible year. It ended up putting a damper, not just for COVID reasons, but also because we didn't have snow. But yeah,
That's too bad. Well, we'll try and save some snow for you up here if we can.
please do.
All right, and then maybe last but not least, Peter asks, with shorter winters, warmer winters, perhaps more midwinter thaws, all of that, and the cost of snowmaking perhaps a little bit prohibited, and and southern city dwellers maybe getting less psyched to ski with less snow on the ground, are cross-country areas toast?
Oh, it's a heartbreaking question, especially since of the closure of what's the name of the one up there? It closed at the end of the year last season, and I'm blanking on the name right now. But it was up in northern New Hampshire, and after 50 years, they had to shut their doors. Um, Snowmaking is making its way to Nordic resorts. It's not perfect, but they're working on it. And you make an excellent point about backyard syndrome, though. So backyard syndrome is what brings skiers from, say, the Boston area to be like, oh yeah, I remember skiing. I like skiing. Oh, look at this big snowstorm we just got, and they actually are motivated to come up north, and this has been documented. Um, we think maybe this might have winnowed off a little bit in recent years, especially since the advent of instantaneous social media. So it's not as easy for resorts to say like, yeah, we got 12 inches, and then someone else is over there, they get 12 inches, they only got like 6. And be able to say have a ground truth from one of your friends that's up there instantaneously contacting you with the pictures to prove it. So I think the backyard syndrome is important, especially because a lot of the skier visits are coming from southerly locations. So if they're coming from Boston and Boston isn't getting as much snow, it doesn't matter if the mountains have snow, they're just not as motivated to get up there.
Yeah, so a little bit of a double whammy that it hurts if they're not coming and not seeing their backyard, and certainly the financial crunch of trying to keep snow on the ground and make snow if they're not already adapted to that, especially the cross-country ski areas that may not be doing that so much.
I hope they're not toast though. I hope they can
Me
hang
either.
out. Yeah.
I like doing it down the street. I would like that to continue. And I'm sure
Mhm.
lots of other folks would like to keep recreating as well.
Yeah.
Well, Liz, thank you so much for taking some time to present tonight, to answer lots of questions. And thank you everyone who's attended. We had lots of folks join this evening, the most so far in our Science in the Mountains programs. So really thankful for everyone who came out tonight. If you enjoyed tonight's free program, please consider becoming a member of the observatory if you aren't one already.
I'm one.
Hey, that's right. Liz just joined again. Thank you, Liz.
Yeah.
Great lead there. And also you can consider donating to help support programs like these over at mountwashington.org. Don't forget to join us for our next couple of programs. So our next one, Tuesday, December 8th at 7 p.m., extreme extraterrestrial weather. So we leave our planet and go to some others to learn about the extremes of space weather with the Director of Education at McAuliffe Shepard Discovery Center. And then in January, as I mentioned, we're going to host meteorologist Derek Schroeder, who will speak about the art and science of long-term weather forecasting. So don't forget to register for those programs and watch any of the previous programs that you might have missed. That's over at mountwashington.org/SITM. And we'll see you all soon. Thanks so much. Thanks again, Liz. Have a great night and take care, everyone.
Thank you, everyone.
Bye-bye.